Welcome to our SerialEM tutorial. My name is Sean Mulligan and I am a Spock at PNCC. First, I'd like to give you a short overview of the SerialEM window. SerialEM is comprised of boxes or object control interfaces, whatever word you'd like to use, that handle different parts of microscope operation. What we're mainly concerned with are the ones that you see on the screen here. That's the microscope control or microscope status and microscope status. Tilt control for screening, not so much. This camera and scripting, camera and script K3, that's a very important box that we'll be using a lot. It stores our imaging states, and additionally we can set them up as camera parameters in this box here. I'll go into more detail a bit later. And we have this yellow one with autofocus, and it just shows you what you are going to be focusing to, the defocus target. Defocus target can be set by going to focus tune and then set target. From there you would type in what you want to focus to. So for screening, a lot of the time that's higher, so we want to go set target, and I'd like to do minus 3.0. And now you can see that defocus target will focus to 3 microns. Important box here as well is this pink one, low dose control. You want to make sure that low dose mode is checked. This ensures that the camera and autofocusing are doing what they need to do as far as scripts go. The rest of this I'll talk about in a moment, and then this final box in the bottom, montaging controls, that'll be necessary for acquiring our low mag montages and medium mag montages if we choose to collect those. There are various boxes, or there are various menus at the top, file menu, that I'm cycling through right now. The important one for us when we first take over the microscope is to go to Navigator and then click appears to the right hand side like you see, and I can now navigate to areas that I click at. So this would put down what's known as a marker, and I could navigate to that area. This is my cross-grading grid. I've loaded a new grid of interest into the microscope, and I'm going to continue the operations with that grid. So the first thing I like to do when I get the microscope and I'm about to screen the grid is to acquire a search image. So I'm going to go to the left-hand box, camera scripting K3, which from now on will be called the green box, and I'll click search. You can see that I have a fully black window, and in the log it says warning, column valves closed or beam off while acquiring image. So I should go to microscope control and open valves. This is because I just loaded a grid onto the microscope. Now that the column valves are open, I'll click search again. So here's a search view image of my grid. What you're looking for here is that there's no clipping from a C2 aperture or any of that. All of these magnifications and imaging states are set up ahead of the time by ourselves, so we're not going to go into too much detail on customizing these settings. But what I'd like to say though is your search and view magnifications and settings will most of the time be left as they are. This goes for the Cryos and Arctica. So I would like to now collect my low mag montage. So I'll go to File menu, Navigator, Montaging and Grids, and then Set up full montage. So a lot of the time we can take the default settings. I'll run with that, but what you can see on here are the default settings. So we'll be moving the stage because we can't unfortunately image shift the whole thing, and we will also use search parameters in low dose mode. So this will be for our low mag montage. If I wanted to do a medium mag, I would use view, but we'll get into that later. And you have the option of using continuous mode. I'll select that because that'll give us a nice little overview. Save non-float data as unsigned integers, and I'm going to do an MRC stack. You also have the option of doing a series of TIFF files if you'd like to look at them individually and don't want to use another viewer like ImageJ to sort the MRCs. But I'm going to do an MRC stack because I just like to have those images as one file rather than having a lot of clutter. So I'll click OK here. And you can see I have LMM already here. So I should talk about where to store. So that's you want to go to our Z drive and then raw data, PNCC, and then your project ID. So for us, since this is an internal training, we're going to use our internal project ID, which is 50414. If this is your first time on the microscope with your project, you'll need to create a folder at this point. So if you don't see it, just make a folder. I'll click in there, and then you want to do your sample ID. So this, we're doing the testing, so I'm going to roll with this one, and then either want to do screening or data collection. So this is screening, and then LMM. I'm just going to name this one LMM2 and click save. Wait for the software to be ready. It centers the stage. You can see that in the microscope status overview. All right, and with down in montaging controls, once the start button is enabled, you can begin the LMM. So let's click that. Down in the bottom right, you can see the status. We are on piece 1 of 40. And once those 40 images are complete, we will be back here. So it's 11:35 a.m. today. Right now when this is started, let's see how many minutes this takes. Upon completion, SerialEM will ask you if you'd like to save the montage. Click yes. That montage is now loaded into Navigator. We now have a low magnification overview of the entire grid. From here, you can get general impressions of your blotting conditions, things of that nature. This is a pretty great grid. You can see that there's a little bit of an ice wedge. We want to take a sampling of the grid during screening to get impressions of the collectability, how many squares there are to collect. You can look around this grid square, see this grid, and see that there are many grid squares that are broken, but it's not too bad. Additionally, we have that band of thicker squares in the top right corner. There's a handful of them we could count, but we want to find where the particle exists, how it looks, and then from that point, get an idea of if we can collect. So to do that, you'd start with a thin square and then move to a thicker one, and then finally a thicker one after that. So looking at this grid, I'm going to start somewhere around the middle and then move to maybe one of these grid squares with a density in the middle. The grid squares with densities in the middle are generally uncollectible. If you're in a pinch, your particle's difficult to freeze, it aggregates. Sometimes you do want to look for those, and you look along the edges. So they can be useful to look at. What I'd like to do for us is start with a thin grid square and then move up to the thicker one. So looking at this in the top left, I have this image display controls. I can zoom in, and then with a left click and a drag, I can move around the grid square. It takes a little bit to load, but it's okay. All right, so looking here, we have thin grid squares with nice ice, and there's not a big density in the middle like these ones. It's not broken. This has a lot of transfer contamination on it. So this one, these four look like ideal candidates. Let's start with the one that I've selected here. I've dropped this marker down. I'm going to go to Navigator and click Add Marker so that I can save this. And now I will go to marker. You can also press go to XY or XYZ. Most of the time, I avoid go to XYZ because the Z height hasn't been calculated for this specific grid square. But if I'm navigating back to this area after I've done Eucentric height calculation on it, I would use XYZ. Microscope has moved over there. We can tell because, again, that red box is not around the stop button. And so tasks, Eucentric rough. Alternatively, I could have verified that it was a good image by clicking View. View is the magnification and camera settings that Eucentric height calculation is completed at. So you can, as you get more comfortable with the software, you can skip ahead a bit. All right, that procedure has completed. You can see there's a decent amount of transfer contamination here. That's not a bad sign. It happens, but I'll avoid imaging any of these, but I have a decent amount of grid holes that I can select. So next, what I should do is one of these holes that I would like to collect on, I will hold down the left shift button on my keyboard and then right click the mouse in the center and drag it to the middle of the crosshairs. I do it that way because of the lag over remote setup. So release those two. You can see the microscope's navigating over there. Click View to verify that the move was accurate. Okay, it was overshot, so I'll just move it back. Try again. View. And that's pretty good. We also need to check that the autofocus is going to be in a good area. This is necessary because of the different rotations, and so then the whole patterning can show up in different ways. This you just need to do on the first grid square of each grid during screening. So I will check that down here in low dose control. Define position of area, I will select focus. So you can see then a yellow circle appears, and also you can see the field of view of my record image, so what I'll be taking a picture of when I do that. Clicking around, left click sets the area that you can shift to. You don't need to shift too far. Ideally, you don't want the beam from the focus going into the hole that you're going to be imaging, but this is a decent amount of space. So something we could do is holding shift. You can then shift left click and move this between. You can see that I have 2.3 microns between each hole, so a decent amount of space. I'll then click none, and now I want to autofocus. All right, autofocus is complete, and it's as simple as just clicking record. All right, there's my image of apoferritin. It's a pretty fantastic grid and image. And so this is our thin area. So I want to now make note of that. I'd write it down in my notebook or virtual notebook, whatever you're using. Good to take notes of your impressions. You can see a little bit of transfer contamination that's over the apo. You can see some of them are overlapping, so it's not a complete monolayer, but that's all right. You have a lot of particles here. I'm going to use these default settings, so whole image, no binning. I'm going to do a TIFF LZW, and I'll click Snapshot. So from here, I'll save it as I have a lot of options. You have a lot of options on how you want to name it. It's really up to you. Whatever you can do to keep things in order. Occasionally, I'll do something of this nature where it's like grid 1, grid square 3, or in this situation, it would be I'd call this grid square 5 because it's the 5th position, just to kind of keep things organized. But whatever translates best into your notes. So I'm going to call this GS5 underscore thin, and then good, because it's a great image. And click Save. Now I will click View again to get that view image. I'm going to navigate to a hole right next to this and click Acquire. So that is a left shift button, right mouse button, drag to the center, release, navigates. Click view to make sure. Yep, that's great. Autofocus. And then record. Another great image. We'll do a snapshot. We'll copy that name and we'll say thin 2 and save. All right. Now what I would like to do is go back to my low mag montage. So I'll double click its position in the navigator and it's been loaded. So you see my 5 square, that was a good one. So I'd like to select this and change the color. Let's go with a green because green's good. Now let's select a square that's slightly thicker. So again, I'm going to skip these areas where there's a density in the middle. Those are not my ideal grid squares. I'm going to go closer to the wedge, but not all the way in. So zoom in, drag with the left click, and you start seeing how the grid squares, they get rounded in and a bit fuzzier as they get thicker. So this one right here, there's a slight rip in the top corner. So let's just select that because this won't be one we'd really want to do automated data collection on. And that's because you run the risk of the entire grid square breaking, and then you can't focus, can't take image, and the program goes haywire. So this broken one, depending on how it looks in this next image, may have some potential. So markers down, I'll click add marker. It's now the red 6, and I'll say go to XY. By doing go to XY, the microscope stays in the Z. So the Z of 71.34 that was calculated on the last grid square. Otherwise, it would go back to the 84, which was what that other grid square was when we set up the LMM. This is a good opportunity to show you the update Z button. So I'll just click this one. Generally, I like to do it while I'm over the square, but this is fine since I'm just showing you. You can see 71.34. This one still has 84. So update Z. That one, grid 5 is now great if you want to navigate back to it and not calculate eccentric height. So selecting red 6, we're on top of that. Oh yeah, so the crack goes all down the center. So again, this would not be one we'd collect on, but it's a great grid to screen on because grid square to screen on because we don't ruin any of the good squares. Okay, so we've navigated to that area. I'm gonna go to the right a bit or left a bit and retake Z or retake the view image. Cool. And now that's their tasks, Eucentric rough. Let's calculate rough. Sometimes the crack can have the carbon in 2 different heights. And so I don't like to calculate Z on a crack. So I'm to the left of the crack and we'll do all my screening over here. So everything will stay at the right Z. So you can see there's different bits of contamination here, transfer contamination. But what's slightly different is this fuzzy one that I'm circling with my mouse. That one may be an aggregate. It seems more embedded in the ice than this stuff that's on top of the ice. A lot of the time with transfer contamination, you can see a white halo exists around the edges. You can see that in both of these, and that just shows you that that contamination's on top of your vitrified ice. Okay, so we have our Z height. Let's remember this time around, I'll click Update Z. It just makes things easier if you need to go back, but it's really not that important. And then we're going to collect on 2 holes next to each other. So I like this one. Drag that to the center, wait for it to catch up, and release. Okay, navigate there, click View to verify. All right, overshot a little bit. Let's go there. If you're having issues with dragging and navigating, you can also select and say go to marker, or I mean left click and say go to marker, and then this will have the microscope do it. So that may be easier depending on how your connection is. So it overshot a little bit. This can be a bit tricky when you're making small movements, but you don't have to obsess too much over its accuracy when you're screening. Cool. So that one's great. Autofocus. And then record. All right, this is a great image as well. So these this grid square would be collectible. Let's take that snapshot. I've left the window open. Let me close it so that I can show it again. So it's window, take image snapshot, click snapshot, and now we'll call this Gridsquare 6. Like maybe thicker. And good. All right, now navigate to the grid square next to it. We'll do that by clicking View. Autofocus. And then click your acquire your record image. Another great image. So that one's been saved, and I'll change this color to green, and now go to blue, or double click blue to reload my LMM. Zoom in and let's go to a thicker grid square. So that would be this one here. I'll select it, add a marker, and then say go to XY. Tasks, Eucentric rough. Oh, you can see this one now has different looking holes. You can see a bit of shading, a thicker side to the holes. This is good notes for your notebook in regards to sample quality. Or like freezing conditions, starting to learn what occurs. Excellent. So the Z's been calculated, and now we just want to take a couple images. So let's navigate over to this one. Cool. That one I'm going to take an image anyway because I'd like to see what this darker area looks like. Autofocus. And then record. You can tell that there's a lot more overlapping of apoferritin particles, and there appears to be a bit of drift. If I click my FFT and then click the zoom there, it might just be the thicker ice that's making it, but it does seem a bit drifty in the top right. So I'd say this one's nothing special. Let's save it though. So again, window, take image snapshot, call this GS7, thick. And maybe, yeah, just bad. I don't know what else to call it. Cool. And now let's take an image of the one next to it. So I will go back to view image. And then let's navigate to this one. That's with left shift, right mouse click, drag to the center. Click view to make sure it's accurate. And I will autofocus and then press record. All right, there's a record image. I mean, the center of the squares don't look too bad. Again, decent amount of overlapping, but I'd say that, I did call it bad, but it's not really that bad. So we can just say thick, and we can call it okay. So these would be ones that I'd want to avoid, but overall, I'd say that this is a pretty good grid. So let's go back to the low mag montage by double clicking it in the navigator. And now we see this. So just because we're having fun, let's change this to yellow. So that's like with a bit of caution. At this point, I want to take a snapshot, but it's increased text by 5. So I want to take a snapshot now of my LMM. So click snapshot, and we'll just call this LMM targets because we have the targets on it. And so this is good. Look at your notes, have it all related, and then you have this this LMM to remind yourself of where the good areas are when your data collection comes up. So click save there. That one takes a few moments, and we'll click OK and imaging snapshots. Again, it's a bit laggy, but just let it do its thing. Give it one click, wait a moment, and it should be fine. So this grid has been screened. You do have the option, of course, to kind of dig deeper in, but I would say that you don't need to do that because of what we've seen. We've seen that the thin grid squares are good, and in addition to these thicker ones. So that would give us many usable grid squares on this we could collect for many days. So that's fantastic. Now what you want to do is, you also have the option of taking a screenshot of this whole view, so then you have the navigator as well. So to go on to the next grid square, what we need to do is we need to close navigator and close LMM2 that's in the buffer and load the next cartridge. So I'm going to click X there, save navigator. You don't need to save the navigator, so I'll say no. And then we will go File, Close, and you'll see in the top that the LMM is no longer loaded. Close valves, script, one line, and from there I will do load cartridge. And looking over at the other one, I could imagine where you'd have notes on this, but we have grid 2 in. That's, it's in slot 2, so let's load slot 3. So I'll click load cartridge, press 3, and click run. The microscope's now going to go through that operation. Red box plus the long operation in the bottom right showing you that it's busy. Wait for those to release control of the microscope to you, and you are good to continue this again as a loop. Thank you, and I hope this was informative.